Okay, so first section we're going to look at is 1.1. Okay, as I said, it's not really trig related. It's more of a review of square roots and the midpoint formula from chapter 1. Okay, it's the only section we'll do from chapter 1, but the part that goes over square roots is pretty important. Okay, so in section 1.1, one thing they talk about is the distance formula. So basically, distance formula is used with coordinates. Okay, we're going to do this in 2D. So we're going to have an x and a y axis, which means each coordinate has to have an x and a y value. Lexi, if I was going to do it in 3D, do you know the name of the extra letter we'd have to add to do it in 3D? Z, yeah, we'd have an x-axis, a y-axis, and a z-axis. So we'd have an x number, a y number, and a z number for the coordinate. We're gonna stick with 2D. Okay. And our goal is, I'm going to graph the 2 points. Okay, I don't know the exact coordinates. All I know is coordinate A has an x and a y value. Coordinate B also has an x and a y value. And I'm going to graph them just like this. Okay, so we'll just start out with that. So there's A, and there's B. Now, I drew them both in the first quadrant. That doesn't matter. You could, how many copies of that do I have? You could put them in any quadrant. It's just first quadrant is going to make it a little easier to think about. And the goal is to find the length of that segment. Okay, that's what the distance formula does. Now, in order to find the length of that segment, what we can do is we can draw a certain shape. Tanner, do you have a guess what shape I can make? And I've got one of the sides there, but I got to add a little bit to it. Triangle. Yeah, we can make a triangle out of it. And the way we're going to make a triangle is take a perpendicular and drop it straight down from point B to the axis. And what you've just done is created that triangle in red. So now what we've done is we've taken our problem that's really about finding the distance between 2 points and reduced it to finding the length of a hypotenuse in a triangle. Okay, we're going to measure the triangle, trigonometry. All right. Does anybody know a theorem that you can use that involves the lengths of the sides in a triangle? Usually you use this theorem if you know 2 out of 3 of the sides, and it would give you the third one. Jemai? The Pythagorean Theorem. Yep, Pythagorean Theorem. Oh, that's okay. So Pythagorean Theorem. But with Pythagorean Theorem, you have to know 2 out of 3 of the sides. Right? You can't be missing all 3. So let's look at something like this. Say you had a point here and a point here. Okay? What I've basically just drawn is the bottom side of the triangle. Okay? If I wanted to find the distance between those 2 points, you know, this is the coordinate 2, 0. That's the coordinate 8, 0. What could I do with those numbers to find the length of that segment in red? Can you tell me? Yep, Colby?
Subtract the x values.
Yeah, subtract the x values. You don't have to subtract the y values, right? Because when you're trying to find the distance of something horizontal, y values don't matter. Just the x's. 8 minus 2. I'm going to do the same thing here. So here's my point. I'm marking the spot of the vertex in the triangle, and I want to find the distance between this, well, keep it in green, this point and this point. So I know the x value of point A. The x value is x1. What's the x value of that point? Yep.
X2.
Right, it's x2 because it's lined up exactly with the point above it, and I know the x value of the point above it, x2. So the length of the bottom side is x2 minus x1. Okay, let's write that down. So x2 minus x1. Length of the bottom. And now we can do the same kind of thing to find the distance between the green dot at the bottom and the green dot at the top. This time, though, we're not going to subtract the x values because they have the same x values. The bottom green dot is x2, the top green dot is x2. We want to subtract the y values. So, Caitlin, could you tell me what you think the length of this height would be?
y2 minus y1.
Yeah, it's y2 minus y1. That's from there to there. Now we know the length of the bottom. We know the height. We're just going to take and plug those two expressions into the Pythagorean theorem. Okay, so Michael mentioned earlier the Pythagorean theorem. But can somebody tell me what is the Pythagorean theorem? Yep, Lauren?
Isn't it like a squared plus, or is it plus, plus b squared or something equals c squared?
All right, now what's a, b, and c? Because I don't see lowercase a, lowercase b, or lowercase c on the board. What are those?
I don't know, what do you mean?
Well, what is, like you said a, but what is a? I don't know what that is. What does a represent?
A side? I don't know, an angle? I don't know, don't ask me, I don't know.
Yeah,
The side.
it's a side. Can you be more specific?
Okay.
The
Because if you were trying to explain the Pythagorean theorem to someone, and you just said it's a squared plus b squared equals c squared, they'd say, what the heck is a, b, and
It's
c?
like the long one, the long side.
Okay.
Which one's the long one?
See?
Yes. So the idea of Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. You can call the sides A, B, and C, Ralph, Larry, and Moe, whatever you want to call them. But whatever you call them, it's leg squared plus leg squared equals hypotenuse squared. Okay. Those A, B, and C are the letters that people normally use, and I knew what you meant. I just wanted to get you to say it. So, leg, hypotenuse. Finding the hypotenuse is the whole goal of this problem. That's the distance formula. Okay, so let's fill it in. All right, so let's plug in that. I'll try to draw it a little nicer. Plug in that for A. Plug in that for B. And that will be your distance formula. So let's write it out. We've got x2 minus x1 squared, so it's the difference of the x's squared, plus, now fill in for b, y2 minus y1 squared, and that's equal to the hypotenuse squared, which in our problem is the distance between A and B. So distance between A and B squared. Now, the goal here isn't really to get a formula for the distance squared. I would rather just have the distance. So what would I have to do to each side so I don't have the distance squared on the right? I just have the distance. But, right?
Find the square root.
Yeah, we take the square root. And that gives us that version of the formula. The square root of everything we just had written on the left-hand side, right there. So when you're using the distance formula, all you're really doing is finding the length of a hypotenuse using the Pythagorean theorem. That's what the distance formula is. Measuring a triangle, trigonometry. Okay, so usually the way they'll give you a problem is give you a set of coordinates, and you just plug it in and get the formula. I get the answer. Now, I'm hoping most people can plug that in, get the answer. What I'm more interested in is once you get the answer, it's going to usually be a square root. Sometimes you have to simplify a square root. That's the part that I really want to focus on. Okay. Sometimes you have to simplify, sometimes you don't. Okay, let's find the distance between those 2 points. Okay, right now, these are unlabeled. I have a choice which one I can make x1 and which one I could make x2. How about Sam? What are my choices here for x1 and x2?
4 and 5 and 3 2.
Well, some of those have to be y1 and y2. So out of the numbers you just said, 2 of them could be the x's. Which 2?
4 and 3 are the x's.
4 and 3. So it's up to you. I would probably, I mean, it doesn't matter if you get a negative because you're going to square it. But I would just call this x1, and I would just call that x2. I just label it in the order I see it. Again, a negative, it doesn't really matter. It's going to square it, it's going to go away. Now, once we've decided that this is x1, that has to be y1. And that one has to be y2. Okay, so now we just fill it in and see what we get. So the distance, and some people, I want to mention it real quick, say, well, can't you cancel a square and a square root? Nope, not when there's an addition sign right there. If you had something like this, 3 squared times 8 squared, absolutely you can cancel those square roots. And just say it's 3 times 8, and the answer to this is 24. But when you throw a plus sign in there, that messes everything up. You definitely cannot cancel those square roots now. The square and the square root. Okay, you just have to do it all out. What I usually do first is just make like a template to fill everything in. That way you won't forget any of the symbols if you write them all down right away. The squares, the square roots, pluses, minuses. Alan, can you tell me, my first one is x2 minus x1. So what's going to go in the parentheses?
3 minus 4.
No, 3 minus 4. Jermichael, the next one is y2 minus y1. So what's going to go in the second set of parentheses?
2 and 5.
2 minus 5. And now we'll do that out and see what we got. Carissa, what's 3 minus 4?
Negative 1.
Negative 1. And then if you square it,
Be 1.
you get 1. Plus, Liz, 2 minus 5?
Negative 3.
Negative 3. And if you square negative 3? 9. And the distance between those 2 points is the square root of 10. This is a problem that if they wanted you to leave it as a square root, you're done. There's nothing else to do there. If they wanted it as a decimal, just on your calculator, type in square root of 10, and it's about 3.16. Generally, if they don't tell me in the directions to round it to a decimal, I just leave it as a square root. Okay, any questions on that one? All right, so take a second on your own and see if you can find the distance between those 2 points. This will be one that you need to do something to the square root. If you don't remember, just stop once you get the distance and we'll do the rest together. Okay, let's take a look and see what we get. Anyone tell me what they got for their answer before we go through it? Yeah, Ellen?
20.
20?
Square root of 20.
Square root of 20. Okay. Anyone else get square root of 20? Okay. Anyone write anything different than the square root of 20? Yeah.
You can write those, I can.
What did you write?
2 square roots of 5.
Yes. So if you wrote square root of 20, you did everything right. You just have one more thing you have to do. All right. So let's go through and see how we get that. So the difference in the x's, x2 minus x1, or you can do x1 minus x2. It doesn't really matter the order you subtract because you're going to square it. Okay, but I'll be consistent. So 4 minus 6 plus 10 minus 6.
4 minus 2.
Oh, thank you. 4 minus 2. Did I do 10 minus 6 right? Yes. So keep in mind what you're really doing right there. You're finding 2 sides of a triangle. That's what this and that calculation are. And then you're plugging those numbers into the Pythagorean Theorem. That's all you're really doing. 4 minus 2 is 2. Squared gives me 4. 10 minus 6 is 4. Squared gives me 16. Square root of 20, you've done everything right up to this step. Ryan, how do you reduce that?
I do like a little factor tree.
Okay, so you can make a factor tree. You can kind of break up 20 into there's different ways. You can do 4 and 5, and then break 4 up into 2 and 2. And then every time you get a pair, it comes out. Or if you want to do it another way, you can break up the number 20, and I would break it up as 4 times 5. Okay? You try to factor the number 20 so that one of the numbers is a perfect square. Okay? 4. Perfect square means it's a number you can take the square root of in your head. So if you break it up as 4 times 5, then what you're allowed to do is separate it into 2 completely different roots. Square root 4 times square root 5. And if you've done it correctly, one of them will usually simplify. Okay, I'll write those steps down. That's how I usually do it. But if you do it as a factor tree, that's fine too. Okay, so you take the radicand, that's the number under the root, and factor it so that it's the product of 2 numbers. One of them has to be a perfect square, if you're doing it with my method. So you wouldn't write 20 as 10 times 2. Because then if I asked you, well, what's the square root of 10? You don't get a nice answer. And what's the square root of 2? You don't get a nice answer. You've got to factor it so that one of them comes out to a nice answer. Like 4 times 5. Okay, so first, factor the radicand. And the next step is you break it into 2 roots, just like I did right here. 1, 2. And out of those 2 roots, one of them will simplify nicely. Okay, we already did square root of 20, so I'm not going to do that one again. Okay. Any questions on the 2 steps to simplify square root? If you're going to do it that way. All right. So let's try, we'll just call this one example 3. Square root of 48. Can someone give me a way that I could factor the number 48? So it's something times something. And one of those things I could take the square root of in my head. Emma?
6 times 8.
6 times 8. So if you're going to do it as a factor tree, you could do it that way, but I can't take the square root of 6 or 8 in my head easily. So I need another way to write 48. Yep.
4 times 12.
Yes. You could do 4 times 12, and then you've taken out square root of 4, which turns into 2. But look at 12. Now we can do 12, because that's going to simplify more. How can you rewrite 12 as a product? And one of the things we'll take the square root of nicely. Hello, Ben?
4 times 3.
Yeah, you could break it up into 12, you can break up into 4 times 3. So that's how you break up the square root of 12. Square root of 4 times square root of 3. And then the square root of 4 gives you another 2. And 2 times 2 gives you 4. Now, it's perfectly fine to do it that way. But we had to break up a square root twice. If you have to do it twice, then that means there was a better way to write 48 in the beginning. So you'd only have to do it once. Does anybody see another way to break up 48 so we can do this all in one step? Yeah?
2 and 24.
What's the square root of 2? Can you do that in your head? How about square root of 24? No. So to do it this way, that doesn't work. As again, as a factor tree, you could definitely do that. But, Alan?
Could you go down that as a factor tree? Because I did 2 and 24, but somehow I got the wrong answer.
Do that? Yeah. If we have a little time after, I can do that, sure. Yeah?
6 and 8.
6 and 8, so we talked about that one already. Because we can't take the square root of 6 or 8 in our head. I'm thinking of, when you break it up, it's going to be a number in this list. Okay, you're shooting to break it up into 2 numbers. One of them is in that list. I mean, that list goes on, 49, 64, and so on. Yep.
16 and 3.
Right, you could break it up as 16 and 3, and then what's the square root of 16?
4.
4. You're done in one step. Okay. So again, many, many ways to simplify square roots. I don't care how you do it, as long as you get the right answer. Okay. So I'll look at the factor tree one after.
You don't have to, I just figured.
Oh, you got it? Okay. All right. So last thing we'll look at is midpoint formula. This formula really doesn't have anything to do with square roots. It's in the section. It's pretty much the only reason we're going over it, and it's an extremely easy formula to use. So it starts off with the same kind of information, except the goal here is not to find a length. The goal here is to find a location. Where is the midpoint between A and B? Where is the halfway point? So think about that mathematically. If you could represent something as a number, and you could represent something else as a number, and you wanted to know the halfway point between those two numbers, how do you do that? Can you tell me what that's normally called? A halfway point between two numbers? Well, Justin?
Austin?
Austin, I'm sorry.
I honestly have no idea.
Think about like if you had your. I said if you could find two things that could be represented as numbers. Your quarter 1 grade, your quarter 2 grade. Halfway between those two numbers.
The average.
The average, exactly. The only difference is with coordinates. If we go back here, coordinates don't just have a single number. right? They have x values and they have y values. So if I have that one and that one, if I want to know what's halfway between those 2 points, it's not only halfway between left and right, but it has to be halfway between up and down as well. Well, there's your number that represents left and right. There's your number that represents up and down. So we have to do 2 averages. So there's the average of the x's. Okay, right? Average just means you add them up and you divide by how many you have. That's exactly what I'm doing in the formula. I'm adding up the x's and dividing by 2. That gives me the average x value. So Nathan, I got to do the same thing for my y's. So what do you think the y part of my coordinate is going to be?
Same as the x.
Just copy the exact same thing
Yeah, with the y.
with the y. So it's going to be y1 plus y2 over 2. Yep. Good. And I try not to think of this as like some other formula to remember. I just think of it as averages. Average the x's, average the y's. That's the midpoint. As long as you know how to do an average. Add them up and divide by how many you have. Okay, so let's finish up by finding the average between, or finding the midpoint between those 2 coordinates. If you get a fraction, you can leave it as a fraction. Or if you want to put it as a decimal, that's fine too. So A is the coordinate 3, 4. B is the coordinate 7, 13. Okay, so take about 30 seconds and see if you can get the average. Okay, see if we can get our midpoint. Kyle, can you tell me calculation for my x coordinate in my midpoint?
X1 minus X2. Sorry, X2 minus X1, right?
So that's if we want to find the distance between them. So when you find a midpoint, what are you really doing? I kind of gave another word, and I think I had asked Austin about it.
Like the average of
You
the
have
two?
average. When you find average, do you add or subtract?
You add the two and then divide by the amount of them.
Yeah. So for your x coordinates, you're going to add the 2, and then divide by how many you have, which in this case is 2. All right. And Sean, can you give me my coordinate for the y values?
4 plus 13.
Yep. And divide by 2. So you're going to get a coordinate of 10 over 2, which is 5, and then 17 over 2, which is 8.5. So big difference between this formula and the other one. This is a coordinate. This is a location. The distance formula is not a location. It's a length. Okay. Any questions on midpoint? All right, so homework tonight, part of it's in the book, part of it is some problems you need to copy. So it's page 7, 15 to 21 odd, 39 to 43 odd. And simplify these 4 square roots. Square root 40, square root 28, square root 108, and square root 1440. Okay, also, the other thing is to have the syllabus sheet signed.
Is that odds for both those sections up there, 15 and 21?
Yes. Okay, so bring back the syllabus sheet signed.